So let's move on now to RF amplifiers. And so in order to talk about RF amplifiers, we're going to use this block diagram of an RF system that has a wireless link between receiving and transmitting sides. And so what we're going to do in the coming videos is we're going to sort of focus on various parts of this block diagram. And then at the end, we're going to see an example where we bring all of that together to look at the entire RF system. So in the block diagram, we see on the left, we have some signal source, which goes into a modulator, then to a transmitter amplifier, to a transmitter antenna, which sends the signal through space to a receiver antenna. So all of these components circled in blue over here on the left comprise our transmitter. Now once we go to our receiver antenna, our signal then goes to a receiver amplifier, to a demodulator, and ultimately to the output wherever it's going to be used. So all of these components circled in red make up our receiver. And so we're going to come back and we're going to look at each of these components in a little more detail, some in this video, some in later videos. But before we do that, I want to just mention that there are several examples of wireless communication systems that use some variant of this block diagram. And so these include things such as Bluetooth, mobile phones, wireless local area networks, or WLAN, wireless local area networks, so our wireless networks, also radio, TV, and satellite links, so things such as GPS. So a lot of different systems have this basic structure, so it's definitely worth our time looking at some of these key components. So let's talk a little bit about sort of this input side first with our transmitter. So what our modulator here is going to be doing is essentially impressing the signal onto one or more carriers. So let's write that out. So our modulator is impressing signal onto one or more what we call carriers. And so these carriers are just different frequencies. And so these certain signals which have been impressed on these frequencies are of course then amplified by that transmitter amplifier and then broadcast by our antenna. So amplified and broadcast. And so of course, sort of the key part here of this modulator impressing the signal on carriers is something that you look at in your communication class in ENG 311. So once we get to this spot, our transmitter antenna is then sending this signal to our receiver antenna, but this is happening over free space. So what we have sort of in this medium in between is some space loss. So we're losing energy as we're transmitting here. And so for that reason, the power at our transmitter is going to be much larger than the power at our receiving antenna. So power of signal at our transmitter is generally going to be much larger than at our receiver. And so I'll just put in parentheses here, that's due to our space loss that I labeled above. And our space loss, as we'll see a little later on in electromagnetics in a later course, is going to be proportional to 1 over r squared. So 1 over the distance from that antenna squared. And this is going to be particularly true if we're talking about an omnidirectional antenna. And so what that means, let's say we have some antenna here. If it's broadcasting in every direction, then we're going to be losing a lot more energy than if we had some directional antenna, which is only broadcasting in a certain direction. So our space loss is usually, to give you sort of an idea of some numbers, it's usually going to be pretty large, and it's rarely going to be less than 60 decibels. So rarely less than 60 dB, and can be up to hundreds of dB or even higher than that. And so ultimately what this means is that our signal arriving at our receiver is going to be very small. So signal at receiver is very small or very weak. And so what that means in terms of signal level, let's say we're talking about a voltage, that means it's going to be maybe on the order of microvolts to millivolts. Whereas on our transmitter side, maybe we had volts up to kilovolts. So what we need then is, if this signal coming into our receiver amplifier is relatively weak, we want to have a special type of receiver amplifier here called a low noise amplifier. So we want a low noise amplifier on our receiver. And so we'll see later, we're going to abbreviate this LNA for low noise amplifier. And so we want to make sure we do that so all of our signal is there and it's not been corrupted by noise before we send it into our demodulation stage. So before we move on to take a look at some specific configurations for some of these transmitters and amplifiers and things of that nature, I want to talk in general about different types of configurations we can have for this transmitter amplifier here. Okay, so right now we're going to consider our amplifiers for our transmitter. Okay, so there's a lot of different types depending on our application. So let's just say depends on application which of these sort of characteristics we want to have. But just to sort of highlight some extreme sort of different ends of the spectrum, we can have a low power transmitter. And so typically that's going to be less than 1 watt on our transmitter. And so examples of when we might need to do this is, let's say a signal doesn't have far to travel. So signal doesn't travel very far. And so what do I mean by very far? Let's say it's on the order of a meter or two. So if that's the case, then maybe we only need milliwatts of power on our transmitter, and that's okay. So of course the dual of that would be a high power transmitter amplifier. And so let's just, in keeping with the definition above, say our high power is going to be a greater than 1. So typically for these high power transmitter amplifiers, we're going to require some type of heat sinking or some other type of heat dissipation. Maybe we have fans as well. And also our efficiency is going to be an important thing to consider, because as we are getting to higher powers, lower efficiency of course means we're losing more power. Because if we have, for instance, maybe a 10 milliwatt system with 90% efficiency, we're losing 1 milliwatt. That's not as bad as if we're losing one watt from a 10 watt system. So another thing to consider with our transmitter amplifiers is the size of the band over which we are broadcasting. So we can have a narrow band or a broad band. So narrow band is going to be just around a certain frequency. So designed to be used in, as the name suggests, a narrow band around some center frequency. And so again, depending on the application, that might or might not be useful. The dual of that is if we have a broadband amplifier, and so that just means we're transmitting over a wider range of frequency. So amplifies over a wide or broad range of frequencies. And so again, I want to come back to a point that I've said in a previous video. Regardless of the type of amplifier we use, whether it's low or high power, narrowband or broadband, we have to keep in mind that the physical layout of the RF circuit is important. So our physical layout of RF circuit is very important. And so this comes back to the idea that I mentioned earlier. We can have the same schematic for two of the same schematics for the same circuit, and if we construct them different physically, if our parts are sort of maybe more separated, or if we don't have things wired a certain way. And so again, this is sort of getting beyond the scope of what we're covering in this class, so that's why it's kind of hard for me to explain, but we start having to talk about things like ground planes and printed circuit board design. But the main takeaway is that this physical layout of our circuit is very important, so we want to keep that in mind. Another thing to keep in mind is that typically breadboards are not good for prototyping RF circuits. So let's just say breadboards, not good for RF prototyping. And so the reason that is because we have a lot of stray and distributed capacitances at these interconnections, so we don't want that to be interfering with our sort of our intended capacitances and function of our amplifiers. So again, what we're going to do in future videos is we're going to come back and we're going to look at various components and ideas related to this block diagram. And then at the end of this topic, we're going to come back and look at a big example related to this block diagram.